cell. A very warm good morning to one and all. I am Aisha Rafiq of the first year Geology, here to host your second day of Environ 2021. Geology is the study of Earth. And you know what makes it more interesting? It is random and unpredictable with a whole bunch of facts. To begin this another lovely day of wisdom, let's join our hands for a silent prayer. Thank you. A really great person is the one who makes every other person feel great. It would be my honor to welcome Dr. Rani MJ, Distinguished Vice Principal of Sahadia College of Advanced Studies, to felicitate the event.
Thank you, Aisha. Dear respected Dr. P.S. Sunil, today's guest speaker. Dear respected Dr. P.S. Sunil, today's guest speaker, Professor Davis KJ, Head Department of Geology, beloved faculty members of SCAS and other colleges, and dear students, good morning. Being a mathematics teacher, I know very little about the subject geology. I only know geology is a branch of earth science concerned with the solid earth, the rocks of which it is composed, and the process by which they change over time. As we know, we are living in a world revolutionized each fraction of the second by mind-boggling inventions, discoveries, and changes in the field of science and technology. We all understand the importance of science, technology, and innovations in our day-to-day lives and the ways in which they are transforming the world. That's why Department of Geology at SCANS, under the able leadership of Professor Davis KJ, is always particular in organizing seminars or invited talks by eminent scholars in the field with an aim to provide their students more awareness about the current developments in their subjects beyond their curriculum. Yet another remarkable initiative by the department is this 5-day lecture series by well-known scientists. I congratulate Professor Davis KJ and team for the effort they have taken for arranging this international level webinar series. Today, we are going to hear about the topic application of GPS in earth science. The resource person is Dr. P.S. Sunil, Head, Department of Marine Geology and Geophysics, CUSAT. Since I am an alumni member of CUSAT, I feel proud to introduce this CUSAT professor to you. As I said, Dr. P.S. Sunil currently serves as an associate professor, head of the department, and chairman board of studies in the Department of Marine Geology and Geophysics, Cochin University of Science and Technology. He received his PhD degree in marine geophysics from CUSAT in the year 2007 and completed his postdoctoral research at Nevada Geodetic Laboratory, USA during 2012. He served as scientist and research professor in different institutions like IIG, DST from 2000 to 2018. During 2011-12, he has been on deputation to Nevada Geodetic Laboratory, USA as a visiting scientist. He is also a recipient of JSPS Exchange Program Fellowship by Kyoto University, Japan, and Boy Scouts Fellowship by DSG. As part of his research activities, he has been a member of Indian Antarctic Scientific Expedition twice and Indian Arctic Scientific Expedition 4 times. He also serves as a research coordinator. Under his guidance, 2 PhD theses have been completed, and he is having more than 40 research publications in his credit. On behalf of Sahardaya College of Advanced Studies, I proudly welcome this great scholar for today's keynote address. I also welcome all the participants to this program, and I'm sure the session will be highly profitable and informative for you. I sincerely wish all the best to the successful conduct of this program. Thank you.
Thank you, ma'am. It was a great privilege to hear from you. Well, GPS or Global Positioning System provides satellite tracking services that are known for its utility in variety of commercial and personal applications. Imagine knowing its applications in earth science, for which I welcome Dr. P.S. Sunil, who is the head of the Department of Marine Geology and Marine Geophysics at CUSAD, which is where our respected Professor Davis KJ is an alumni of, to grace us with his knowledge.
Sir, please.
Sir, can you please unmute your phone?
സാറേ ഇവിടെ ഞാൻ അൺമ്യൂട്ടാണ് ഞാൻ അൺമ്യൂട്ടിലാണ് അൺമ്യൂട്ടാണ് ഇവിടെ ഇപ്പൊ കേൾക്കാമോ? Am I audible now? Now it's audible?
Yes, sir. It's audible now.
Yeah, thank you very much. A warm good morning to all of you, and thank you very much for inviting me to this seminar series as a speaker, and nice words with the introduction. And once again, my sincere thanks to the principal, vice principal, and Professor Davis Jacob sir. And indeed, it is a great pleasure, and it's a nice moment for me to interact with the upcoming geoscience students from the Sahardaya College. And I think already yesterday there was another speech by scientists from NSS. Today we will be mainly dealing with the GPS applications, though I have given the title as a GPS application in earth science. Little bit, just I will be touching the earth and atmospheric science, because this is one of the tool which can use for many applications, because generally everybody know that because including our mobile phones, day to day our routine life, we deal with our GPS for locating positions, and including even for the delivery of your food items. Because of the pandemic situations, people will be keep on booking the food items, and this delivery boy used to come with the GPS, right? And apart from that, this is having a lot of applications. And these applications, some of the scientific applications which are very well utilizing for the scientific activities in earth and atmospheric sciences. And today we can discuss some of these applications. I don't go much detail into the theoretical part of these applications. However, to give a better view and better knowledge, being a geoscience or geology and geophysics students, I think it would be a nice, I thought it would be a nice chance to express or deliver this talk in front of you. Let me share with this slide. Is it visible? Hello?
Not, sir.
No. What about now?
Yes, sir, it's visible now.
Yeah. Because when I gave a title to the Davis sir regarding this talk, I gave us applications of GPS in Earth Science, Earth Science. Because they just a bit elaborated here. So applications of GNSS, that means Global Navigation Satellite System. Or bracket I put GPS. We can discuss what is the difference between this GNSS and GPS, and how it can be utilized for this Earth science, as well as because atmosphere also part of our Earth, and how it can be utilized for our research or our day-to-day activities, or apart from that, these applications, how it will be utilized for the society apart from all, because whatever research or whatever education or research we do, we should have some deliverables for the betterment of the society. How it can be very well closed with the society in terms of scientific activities. Here, the picture in the left side, it shows, because the GNSS or GPS, whether any difference is there or not. Because always the term we use, it is a GPS. Actually, the GPS is a part of GNSS, that is Global Navigation Satellite System. Because under this Global Navigation Satellite System, there are a lot of, not that much, but there are other the devices or the equipments like GPS systems are there. And when we talk this, all the different navigation system, this navigation system we can call it as a global navigation satellite system. Here you can see some of the satellites which is orbiting, in the polar orbit or geosynchronous, different way it is orbiting in their particular orbital plane in around our Earth. Here you can see some names: GPS, Galileo, GLONASS, Beidou. These are all are as a part of GNSS only, but different countries, they operate for their own purposes to locate the primary aim is to locate their position only, of course. Then from that position or the signals which we receive from the satellites only, we use that signal for different applications. And this global navigation satellite system, this is a constellation of satellites providing signals from space that transmit its position and timing data to GNSS receivers. Because generally we will be having receivers, whatever in our mobile or whatever in our some handheld GPS or some other GPS which we use exclusively for the geoscience, that are in the receiver side, and the signals it is used to send from these satellites. These all satellite system like GPS, Galileo, GLONASS, and Beidou, we can call it say GPS, GNSS. And GPS is part of that GNSS system only. And like GPS, it is a satellite navigation system which has been operated by the US Department of Defense or US Army. They have, during 1980s, they have started for their positioning purpose related to their Army or Department of Defense. And later on, this technology has developed like anything. And then people, they thought to think, why don't we use this signal for different applications? That way, these applications has come up like for different research as well as so many applications like Earth and atmospheric sciences. And same way, the Galileo is another global navigation satellite system which is operated by the Europeans. Another one is a GLONASS. It is this is also, it's like in Russians, it is generally it's a global navigation satellite system only, but the short form is GLONASS again. And the China also having another their own satellite system, this Beidou. And of course, our India also not much behind. We also it is the commission or the launched our own indigenous satellite navigation system. It is called Indian Regional Navigation Satellite System. We also have, because it is from last the half decades, is almost it is in the track, and under ISRO, the Space Application Center Ahmedabad, they are in the making of satellite receivers. Now most of the universities also different projects that even for the research purpose we can have these receivers which can be under this our IRNSS, that is Regional Navigation Satellite System by India. And this also, it is already in the system to track the signals, and we can make use of the satellite information for the positioning and different purpose. But still, since it is in the initial stage, compared to the other navigation satellite system like GPS or Galileo, is not that much accurate. But still, for our positioning purpose, is very useful. And accuracy in the terms, I am talking in terms of some millimeter or centimeter level accuracy. Of course, it can be a long-term data collection. It is possible, but it is since it is in the initial stage. I think within a couple of years, we also will be able to produce our locations in very precisely. Very precisely, I am talking. It's a centimeter level. Of course, it can give 1 or 2 meters accuracy. Definitely, our IRM is also now capable only. And generally, now, especially because the GPS is one of the oldest, as well as this is it is worldwide, the signals are available, because all the countries, they can have their own control to give the signals to the layman use or the public usage. Now, GPS signal is very well available in the globe, because with the GPS receiver or GPS our mobile phones, which is already there, some receivers are there in the mobile phones. We will be able to track these GPS signals, so that it's worldwide. It is available. But why all the countries they have developed their own the satellite system? Because we don't know, anytime this America or any other countries, they can stop this the sending of or the availability of these signals. By that time, the other countries will be in trouble. Accordingly, all the countries, they started to think of, and in the same way, India also thought. Now, even if the GPS or the other like GLONASS or Galileo, even if the other countries they stop also, we need not worry about to move around. At least in our IRNSS case, Indian satellite case, we can anywhere in India we can move without any issues. That's the way this has started, and mainly almost the principle, everything is same for the Beidou or GPS or Galileo and even IRNSS. But still, I will be mainly focusing with in the case of GPS, which is one of the oldest, and mainly now the signals are available for everyone, and these signals can be used for all applications, including our Earth and atmospheric sciences. And here you can see this is the GPS is having, or even GNSS is having, mainly 3 segments. The first one is the satellite constellation or space segment, because this is the part of the satellites which is orbiting in the space. And second one is called the control segment. That control segment is mainly located in different parts of the globe, and these control segments keep to track these satellites, and this health issues of the satellites or signal issues of the satellites, and because they keep on track the satellites and monitor the satellites, and it is keep ready to provide the signals to the entire globe. And the third one is called the user segment. User segment part is VR, because we have those who use that signal for different purposes, like our positioning or like our scientific activities. We were in the user segment position. And here, this slide, it shows that a satellite constellation in the space segment. And here you can see there are a lot of GPS satellites. It is almost, if we count, it is maybe more than 32 satellites will be there at a time. And minimum it should be, because when we the GPS, the launching they started, it was supposed to be the 24, but later on, it depends on the keep on updates. Now it is almost 31 to 32 satellites are available. And these satellites, in each orbits, because you can see there are 6 orbits are there. In each orbits, they have 4 orbit satellites. See, this is let us see. This is one orbit. This one is orbit, and each orbit they will be having 4 satellites. Like that, total 6 orbits. 6 into 4. There are total mainly all the time 24 satellites will be keep on. It is moving around. Why? Because another 24, 6 or 8 satellites are there. Still, because since the coverage they wanted to be more, and these satellites it will keep on orbit this orbital plane, and this is located at an altitude or height of 20,200 kilometers away from the surface of the Earth, because this is the height of this satellites is 20,200 kilometers height altitude. And these satellites at one satellite it twice in a day one orbits complete. That means in a day 2 times it's keep one orbital. It's whatever it will keep orbit. That means one satellite twice in a particular plane it will keep on move. And this is the satellite. This GPS satellite looks like this is in the space, and these are the main signals and these sending devices. This is the solar system, and this is when in the lab this is used to be like this only, this GPS, and this is the constellation. And why they made this constellation of this satellite like indicate means minimum at any place in any place in the globe. If you go in Thrissur or Ernakulam, anywhere in open place, you should have minimum 4 satellites to track the your positions. Minimum we should have 3 to 4 satellites. Then only we will be getting minimum our our positions like latitude, longitude, and height. And the 4th satellites mainly for the time in very accurately. And this is the constellation part of this GPS. And the second is the controlling segment, and it is called the controlling stations. These are the in globally they have different controlling stations. And mainly the master control stations, and they used to these all different control stations like these circles and these triangles. They used to keep on track the satellites from different part of the globe. And if any satellite is having some technical issues, they will immediately pass on the message to this main control stations, or they will try to rectify from there, and they will send the message to the control station. This control station it will update the status to each satellites, and this is the way. These are the people they control these GPS satellites from different parts of the globe and this segment is called the control segment. And the third segment is the user segments, where we are, because these segments it can be utilized mainly because in user segments means from when the day starts, we just take your mobiles. From there onwards, you start to use the signals from the GPS, right? Whatever, whether any when you go to your college, or when you go to any office, or wherever you go, nowadays this smartphones, everywhere GPS is there. And even if you unknown place, if you go, you have to just switch on your activate your the Google Map or the whatever apps in your mobiles, and you just go, because there is a small device of this GPS receiver is installed in your mobiles. And because now it's like it is part of our life, it is now became that way. And here you can see in even your navigation purpose in the offshore, whether in the ship or in the aeroplane, or in the road, or in a remote place like a forest or anywhere you go. This GPS signals, if you go to the open place in the sense, if you are in the inside the building, or if sometimes if you are in a very dense forest, the forest, like your mobile phone signal, sometimes you may not get it. The same way, even some depends on the position. So suppose if you are inside the building, you may not get it, but if you just go outside your building, definitely you will be able to track minimum 4 to 5 satellites at a time. That is the way the constellation of these satellites they made it. And this is the main our position. And this even generally the satellites the receivers we will be having like this like a handheld GPS, which generally we can call it a handheld GPS. I think the cloud cursor, let me point it. Yeah, this is our handheld type GPS, or the same type of GPS on the inside also in the mobile phones. And some survey, the very accurate survey purposes, we can use this type of, this is called a geodetic, or the DGPS type of receivers, this type. And for the earth sciences as well as the atmospheric sciences, we can use, this is also another type of GPS receivers only. And this is very well connected with our earth ground. Here you can see this is the ground exposed bedrock, and this tripod, or this is very well connected, is tight with because this is not just they put it on the surface, because it's almost it is drilled inside this bedrock and very well fixed. And this is the way we can use this data for whatever informations we collect from the GPS, we can use for some earth science applications. That part I will come, how we can use these informations apart from these positions, because this handheld GPS or GPS which we are using in our mobile phones are mainly for our just position, and find out, like if suppose if one person, if I am coming from here to your college, if I am not able to, the first time if I am visiting, and without inquiring to anybody, just put your latitude, longitude, or search in the Hardware College in the Google Map, and just start the trip, and the GPS take me directly to your college. And that is our routine usage of this GPS signal. But apart from that, like a very precise positioning or mapping, because suppose you must be aware about that geographical information system for making the maps, very precise map, because that is one of the main input we mainly get from the GPS or global navigation satellite system only. The same way, because being a geology student, or being a geology and geoscience researcher, or being a geology and geophysics academician, we can use the another type of GPS receivers. This is called geodetic GPS receivers. This we can use mainly make use of for the other applications in earth science, like the plate tectonics studies, or atmosphere, even including our weather prediction. All informations we can use, and how we will be, even for the groundwater detection, all we can use, and how we will be using for this information. Just in the coming slides, I'll explain. It is clearly audible, no? There is no technical issues, right?
Okay, sir, it is clear now.
Yeah, fine, thank you. Yeah. And here you can see generally the microwave radio frequency, it starts to this used to send from the satellite. There are two type of signals. This is called L1 and L2. I am not going to the much technical details of this satellite. I thought to make it as simple as possible. And these signals, because it should have a line of sight. So that's why I was telling, even if we are inside any building, or some obstructions are there, sometimes the signals may not reach the receivers where we are. But if it is used to send a microwave radio frequency, and there are two types of frequencies, are L1 and L2 frequencies are there, and it should have a line of sight. and this can pass or penetrate through the clouds or glass or plastic items, and generally blocked by the buildings or mountains. Some obstructions are there, and sometimes if the signal is very weak, sometimes under the trees also, sometimes we maybe the signals can get deviated according to. And this again, and this one of the another important thing is the GPS receiver compares the time signal was transmitted by the satellites with the time it was received. The time generally when the satellite starts to send the signals from the GPS, and it used to give the informations in the starting time of that particular the pulse the signal pulse, and it reaches in the receiver side and receives in the when it receives. Then we will be having the information about the start time and receiving time, then the time delay, and if we know the frequency of these satellites, then we can find out the distance. Then I will show how it is coming. Generally the signals that travels at the speed of light. Here you can see the speed of the light, and this is a simple way I just thought to explain how we will get the positions. And as we discussed, when it starts from the satellites, it will be having the information of the starting time, and when it receives, there will be a time delay, right? And this time delay, it is then if we multiply with the speed of this or the frequency, our speed of that particular signal, and the distance which we are getting from the starting and the receiving time, the delay, then we can, if we multiply, then we can find out the location, the distance, our location from the particular satellites. And this is in the case of a single satellites. There we will be having only one information. Suppose if you have a GPS with GPS receiver with one satellite only there available in the space, then only we will be having some information that we are just simply this much kilometer distance, 20,446 kilometer away from the satellites. But we may not be able to provide our locations, because we should have more satellites at a particular time. Then only we will be able to get. And this is the way the signals generally what happens. We will be having the GPS satellite. It is having a very atomic, because this is the one of the important part of this GPS. All the satellites is having atomic clocks, and this is very precise. It's the parts per millions. The precision is there. That's why this system also very expensive. In the case of our handheld, of course, we may not be using that much accurate, but signals which is coming from the satellite is fine. But in our mobile phones, it is not that much accurate. But in the case of the geodetic receivers, which I show here, these all are very precise. The clocks also very expensive. Accordingly, the cost of these receivers also, it is like suppose if we go for this type of a GPS receiver, it will be the cost will be around 10 to 15 lakhs for a single unit. And if this is for the survey purpose also, it will be like that, some 10 to 12 lakhs different. The cost will be there. Suppose, whereas in the case of the handheld GPS, it may be some 10,000 to 15 or 20,000 rupees. That is the difference. It comes. That depends on the clock's informations which you will be having, because the important parameter the information. If suppose for the accuracy, we will be having a very precise time informations. Otherwise, this will be, suppose if you are like already whatever the information which is coming from the satellites, and your mobile phone timing is not proper, or the receiver timing is some delay is there. Suppose let us see it is already at a 2 minutes delay, then the estimation will get an error. Accordingly, then when we go for a very precise measurements, we should have that much accurate clocks, both in the case of satellites. Of course, satellites is having atomic clocks, and this is already inbuilt there. But whatever the receivers which we use in our user end, we should have for the application. Depends on the applications how, because for our, especially in our case, like the geoscience students or researcher, when we go, how we will be measuring, I will be coming. our accuracy, we should have an accuracy of millimeter. Then only we will be able to measure our earth surface movement, like a plate tectonics. When we deal, you know that our plates are keeps on move in different directions, and these plates are colliding each other, and because of the collisions, the mountains are forming, or because of the sea floor spreading from the spreading center, the trenches are forming, and because of this collision, the earthquake get generated. These all informations, everything depends on the our crustal movements, crustal plate movements. If we want to, these plates are moving in a very slowly, like 2 or 3 centimeters per year. That means very small movement. If we want to measure these movements, then we should have our the equipment which we are using, whether the GPS or whatever equipments you view, that should have a very the precision should be very it should be very precise, as well as the accuracy should be very very much accurate. Like if you can measure with the accuracy of 2 or 3 or 4 or 5 millimeter, then only you will be able to estimate the movement of the crustal plate in a centimeter level. Otherwise, if your error is in a meter, then there is no usage or there is no use of spending this much lakhs for the study. That way, this is generally what happens when what happens when the signal sends from the satellites, and the same time the GPS receivers also send, the receiver clock also will send the satellite the signals, and they synchronize each other. That will be the time difference or time delay. That is how they will estimate. And this time delay, if we multiply with the frequency of these satellites, then we can get the range, that is, or the distance, that is called the pseudo range. Accordingly, the radio signals from the satellites tells the GPS receivers the satellite probe time and provides the most recent corrections to the satellite position related to the Earth. And accordingly, then we will get the pseudo range from one particular satellite. If we have more than 3 to 4 satellites at a time, then using this, you must be in your plus 2, 10th or plus 2 level. We must have that in trigonometry. We know that if we know 2 to 3%, then we will, for the trilateration or triangulation method, we estimate the position of a particular object. The principle used here also. If we know the GPS receivers compares the satellite time to receive time to determine the distance to each satellite. And if we know that let us we are starting with the GPS receiver here, and the first time we will be getting information of from a particular satellite, because the satellite is moving in this orbit, right? And no, it is not from this orbit. It is moving in just we are getting information that this particular satellite is almost 20,400 kilometer height from this position. And we will be having another, then we know that we are in a position some toward these circles. We can be anywhere in this circle because we are getting only one satellite information. We don't know whether our position can be here or here or here or anywhere in this part. But if you can project this part to in a planar view, just you can assume, no? Because suppose if you are standing here, if you are getting information, then that means this error can be, position can be anywhere. Then if you have information from another satellites, then your position or the ambiguity has reduced to this much area. See, now you can be either, if suppose the first satellite and second satellite, and then you only the information from the first satellites, your position can be anywhere in this circle. Suppose another information from the second satellite, then you will be coming to know that, okay, I will be in somewhere here in these 2 positions only. The third satellite, if you have information, you will clearly, you can say that I am not anywhere in here or here or here. I am especially in this here only. And if keep on add the more satellites, your accuracy will be getting increased and increased. Of course, there will be a lot of other error factors are there. Just we will discuss. And this is the way we find out a location or just for a single position. And when we come to our other applications like for the earth science or atmospheric science, there are a lot of error factors are there which will contribute to the signals, and depends on these error factors, your position or whatever you are estimating. Suppose let us say our position in I am sitting in Kochi Pallimukku, and if I go just outside with my GPS receiver, and it is saying that your position is latitude is this much and this longitude is this much, and when we purchase a GPS receiver like a handheld GPS, the small one, or when we purchase a receiver with the geodetic receiver which I showed, and they may say your the accuracy you can the precision will be this much, and you can measure up to an accuracy of this much. They generally because this is all an expensive instruments, right? And they will give. Then suppose they are the geodetic receivers which I am showed in the tripod or this one, they will show this accuracy like within say sub-centimeter level. That means by using that GPS you can measure your position within a sub-centimeter level of accuracy. Means if suppose let us say it's a 2 centimeter or 1 centimeter, that means if you measure your point, you can tell that if you just draw a small circle, that means one centimeter diameter circle, that means your position will be in that small circle. And if they are saying this receiver is having an accuracy of 5 the error of 15 meter, means even if you measure with that handheld GPS or mobile and whatever mobile which we use, generally they say 15 to 20 meter error. Error means what? Even if you suppose, that's what, just simple example I will, you go with your car, and this is saying, just you are coming to the Lulu Mall, and you don't know, you first time you are coming, and this GPS shows, after coming to Kalamasheri, it may take, I think you must have come visited this area, and Kalamasheri, this is showing some other directions. That means Kalamasheri and our Lulu Mall is having some quite few kilometers, 3 or 4 kilometers. That means the error of that GPS is having almost a big error, that is like kilometers of error, because after reaching there, that GPS itself it is getting confused. I don't know whether the Lulu Mall, it is not able to locate that Lulu Mall. Suppose some GPS is having more accuracy, means if again closer to Lulu Mall, once it reaches some 100 meter or after reaching to 100 meter, it is getting confused. Sometimes it may go the direction to the left side, sometimes it shows the right side, but that means it is getting confused that okay, Lulu Mall is somewhere in that 100 meters of error circle. That means that is the error circle. Suppose again some good GPS receiver. Hello. 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 Am I audible?
Yes, sir. You can proceed.
Okay. Perfect. Yeah. If suppose if again some good receivers means just we are again okay 100 kilometer also it was showing the proper direction. Again we are closing. Then after coming 10 kilometer, of course, after coming 10 kilometers, 10 meters, you can see that okay, Lumal is there. But still, if it is showing some confusion within the 10 meter, means your error is 10 meter like that. And it's the same way. This is the general type of errors. If suppose if when we buy a handheld GPS for the your field work or this one, then they may tell your the error. It will give the 15 meter error. That means it may not be that much accurate for the study of suppose like a plate tectonic studies, all those things, but it can be used for just for the locating some of our sample collection for when we go to the GPS field site to collect the rock samples. When you go there, you just for locating the position and note down and coming back to your lab or college and making the map, and it is fine for. But when we go for the precise measurements, it may not be that much accurate. And this because apart from because you will be having in that area with so many more than 5 or 6 satellites will be there, and more than what we can say, this open space, everything is clear, and you have a geodetic GPS also, which is giving a very precise measurements like this one. Okay, still you are having once you measure this one, you will be having some errors like meter, 1 meter or 2 meter. That means, but you are not purchased that equipment for this much error. Because again, what is the problem? It is not because of the open area space, or it is not because of the coverage of the unavailability of satellites, because some of the other parameters it is getting affected in the signals. That all can contribute for the as a error in our positioning. These are some of the sometimes is selective availability. The availability, though the satellites will be available, but still the signals may not be that much strength. Then satellite orbit positions issues can again contribute to some more errors, and satellite and receiver clock errors can give us some more errors. And apart from that one, in the atmosphere also, from the ionosphere part, that is it's a layer of our upper area. There also you will give some, because where the ionosphere is a part of the altitude which starts from almost from 80 kilometers in the space. There the more iron particles or charged particles are available. Depends on the electron contents. More charged particles like electrons will be available. Depends on the density of the electrons. The signals may get delayed. The GPS signals which is coming, because signals is coming from, I told, 20,200 kilometers altitude. When it starts to reaches this ionosphere, the ionosphere is not, it starts from, when we measure from the surface, it starts to 80 kilometers to 300, 400 kilometers in the space. And because of the electron content or charged particles, these signals can get disturbed or it can get delayed. And the same way for the meteorological studies, for atmospheric science studies, because if a more more cloudy or more water vapor content in the atmosphere, there also the signals can get delay. Accordingly, your position will be getting error. And then there are other multipath error. Means if you have some reflective materials near to, like a glass building, or some asbestos sheet or some aluminum sheets near to your suppose if you just went outside for a very precise measurements, if and your nearby area there is a lake, if there is a lake, or if there is a aluminum sheet, what happens? The signals comes from the satellites, it get reflected from the this reflective media, and it comes to our receiver. Then accordingly the delay will get increased. That also it is possible. And apart from that, human errors, of course, these are some of the error factors it can contribute. Then all those things we have to eliminate when we study for a very precise measurements. And when you go use this data for this mapping purpose, apart from, okay, of course, for just for position is fine. Apart from this mapping purpose, or apart from this apart from this simple location, if we use this data for the mapping of the entire area, surface of the earth, or in any place of the earth, or if you use for this information for the deformation which is taking place over the earth, or like plate tectonics or earthquake. This is subject is called whatever the measurements we take for the like gravity measurements or plate tectonic measurements. This subject is called a geodesy. This is one of the upcoming. Of course, it is a old subject. It's a part of mathematical science, and also it's earth science. But now these GPS or global navigation satellite system all comes under the subject is called geodesy. And always when the geodesy when we discuss in terms of our what we can say, our positioning, our measurements, whatever changes, whether it is a gravitational field change or whether it is the shape of the earth depends on because of this the rotation or the revolving the movement, or because of the this plate tectonics or seafloor spreading changes or earthquakes, whatever changes comes, this all comes under this geodesy part. And this information, the geodesy, we can, of course, we can from the surface also we can make the measurements, but to get a more coverage, now satellite or space informations are, or the satellites are more accurate, and this is nowadays called, it is a space geodesy, now satellite geodesy you can say. There are, apart from the satellites GPS, there are a lot of other techniques or equipments or the natural agents are there to study for these deformations. And this also, if nowadays in Kharagpur IIT, there is a master subjects they have started for the MTech in Geodesy. It's a Tectonic Geodesy course also they have started. Exclusively they will be studying or the whatever deformations or whatever changes happening over the earth surface, like our for us being a geology or geophysics students. For us, it is like whatever changes due to the plate tectonic activity, that will be the main studies we can measure. And these 3D positions or relative positions that we can use the different techniques. This all comes under the satellite geodesy, because I am not going to much details. Like this another is called a very long baseline interferometry or satellite laser ranging, and synthetic aperture radars are there. A lot of other techniques are there, but mainly we will be dealing, because this GPS is one of the tool which can be used for many applications in their science as well as atmosphere science. That is, and compared to other equipments, it is a cost effective also. Comparatively, even though it is I told it is 10 to 15 lakhs, compared to other equipments, it is quite cost effective as well. This and a lot of applications are there. And just now this application side I will come. And here for the solder purpose, see, this is the GPS satellites. This signals. This is the let us see. This is our Earth surface, which is subducting here, and this is colliding each other. And because of the collisions, there will be a lot of earthquake generations, and from the stress, then accordingly the surface will get deformed. Then a lot of signals, interchange of signals from the satellites, as well as the coupling between the Earth and atmosphere taking place due to this tectonic and associated earthquake activities. And these signals how we can make use of. Just finish some whatever some studies. Just not much go in details. And this is for the solder case. This we can use for the plate tectonic activities and interseismic strain accumulation, because the plates are getting collide each other. Then because stress is getting built up, and because of the stress build up, there will be a deformation taking place, and because of the deformation, there will be a sudden earthquake can generate. This earthquake can be a very it's casualty, or it can create a lot of casualties for the lives. And this type of activities, let's say, we can interseismic stress. That means long-term stress build up due to this plate tectonics. We can find out these GPS measurements, and the earthquake rupture when after this interseismic accumulation, when the earthquake gets triggered, then how this movement is taking place, and how in which direction this earthquake rupturing or the tearing of the particular plate in the subsurface, that we can find out. And after the earthquake, how this is getting again deformed, and what will be the possibility or probability of earthquake in the future. Because when we talk in terms of earthquakes, we are not in a position till now to predict the earthquakes, of course, but still we can delineate the earthquake prone area compared to earlier days very precisely, and we can warn the government and warn the society to depends on the building construction. Of course, all those things are happening also, but people are not taking it much seriously. And this type of earthquake zonations, we can very clearly use the GPS application, and the rheological or whatever the changes happening in the subsurface we can find out, and magmatic process, and proper reference frame. Nowadays, whatever we should have a reference frame to measure all the measurements, and GPS is one of the best tools to make the reference. It is called the International Terrestrial Reference from ITRF. And now this is the for the making the reference frame we can use. Then atmospheric part, when we use this signal, because the signal is coming from the satellite to the surface, this is passing through a lot of atmospheric layers, and depends on the delay which we can calculate very precisely. We can find give some information about the climate change, as well as the ionospheric, as I told, the electron content change, and tropospheric water vapor content change, then atmospheric winds. A lot of usage we can use using the same GPS. And here you see, like our Earth, because I need not to explain much, because you are all our geology students. We have different layers in the subsurface of our Earth. The same way, our atmosphere also having different layers: troposphere, stratosphere, mesosphere, thermosphere, exosphere. And here it is our ionosphere comes in this thermosphere from the 85 starts to here, and this is the area where we'll be having a lot of ion content or electron content, and mainly these electrons are for the communication. How it is used for your communication, like whatever mobile communication information, all it is depends on the electron, because you must be heard that when the solar activity or something, your communication gets disturbed. That means this electron particles get more disturb the signals, and this information using this GPS signal we can find out and how. And apart from when we come to our earthquake studies, and here this is called a tectonic geodesy. I told what is geodesy, and when we use this geodesy or GPS geodesy for the tectonic part or the plate movements or the collision of different plates and associated earthquake, this is called a tectonic geodesy. Here you can see the earth is, you know that both the two plates getting collide each other. One plate undergoes and another one is the override, and this undergoing plate is called the subduction, and other one is called the overriding. Because of this subduction and overriding, you get earthquakes in the plate boundaries, and whatever, because of the, here you can see the plate, the stress accumulation is from this both the side, and accordingly because of the elastic nature of our lithosphere, our generally this plates gets bent because of this collision activity only, because we know that Himalaya also keeps on increasing the height every year by 1 to 2 centimeter height. It is getting increased because recently also last year you must have read the new height of the Everest, right? This all happens because of the this plate tectonic activities, and these informations very precisely we can make use of the GPS data positioning, and this is our plate boundary. And nowadays in the globally we have a lot of permanently occupied GPS stations are there. If we can, these are the dots are the different countries they run GPS permanently, and this data, if we can very precisely, you can use this data and you can very precisely measure your velocity of the different plates in a continuous velocity. Here you can see this Indian plate, these arrows, this indicates Indian plate movements. Our Indian plate is moving almost 4.5 centimeter, approximately 4 to 5 centimeter per year. You can imagine our Indian plate is going in northeast direction for 4 to 5 centimeter per year. Because of this collision, it is colliding with the Eurasian plate in this area. And because of the collision, the Himalaya is getting uplifted, and after a lot of earthquakes keeps on happening in the plate boundaries. And same way, along all the plate boundaries, you will be having a lot of earthquakes. And the earthquake which is happening in the plate boundary, it is called an interplate earthquake. And because of again the stress accumulation, there will be chances of inside also earthquake possibilities are there, like our Idiki dam earthquake or Bhuj earthquake. This is called an intraplate earthquake. But in Idiki or Koina, another term also we can use, that is called induced, reservoir induced. Because of the dam construction, the water loading also get pressurized, and again because of that one, lot of earthquakes. Then if we just talk in terms of different earthquakes, the boundary earthquakes are called the interplate earthquakes, whereas the plate which earthquake happening inside the place is called the intraplate earthquake, and some earthquake because of the some anthropogeny or human activities like dam construction or building construction or groundwater extraction, we can call as the what we can call it is induced type of earthquakes. And this is the very precise measurements of the different global plates in different directions from the GPS. And here you can see this 25 millimeter is a 2.5 centimeter. Here you see, suppose this is a scale. Even Indian plate, if you compare this scale and this one, it is coming around 4 to 5 centimeter. That means that much accurately we can measure our plate movements, and with and the error is like 2 to 3 millimeter error. That means even if you 2 to 3 millimeter error, within that error limit, you can measure your plate movements in a what we can say centimeter level. That is quite amazing, right? That way this GPS can be used. And this from these velocity informations, we can find out the seismic zonation. Like this is a global one. In the locally also, we can see where the stress is getting accumulated and where the possibility of more earthquakes. Like that, we can study. And this is the studies from our Indian group because of time consumption. Because this is submitted published by Jade et al. CMAX Bangalore, and this is Chinese group. And this is our Indian plate movements. And this is the exclusive measurement of our GPS. Indian plate movements, it is showing in a northeast directions, and this is colliding with our Eurasian plate, and lot of earthquakes keeps on happening. And this is the way as I told, no, the different types of possible, this is the GPS receiver or antenna, and we will be measuring this is in the, we fix the antenna on the top of the bedrock, or if we don't have any exposed bedrocks, we can make use of these pillars. Then this pillar also, it is a foundation is made almost the same height in the subsurface also. That much it is coming from deeper level. That means whatever deformations happening because of this plate activity, we should, that's what the human error should not happen, because that way this pillar is having the foundation below also. That much is almost same height. It is 2 to 3 meter height down also there. That means then we will keep the track the GPS signals from the satellite, and this information we can make use of by 3 to 4 the particular location. We can very precisely we can measure. Of course, this data, not the information getting from the real time. We have to process the data. We have to eliminate the other errors like ionosphere, troposphere, all the errors we have to eliminate. Then we can very precisely find out the locations. And this is our studies by when I was in IAG. This is from my group only. This is our Indian plate velocity, and we can find out some reference frame also by using this one. I'm not going to details because you may not be. And from this was one of the studies in the northeastern side of our Indian region, and how we can find out. See, this is the from the GPS velocity information, how we can find out the maximum in terms of seismic zonation. This is the stress in the strain accumulation happening because of this collision of Indian plate with the Eurasia. This is the area where we will be having more strain is getting accumulation. That means more deformation is taking place, the more chances of the earthquake. This type of studies with a more and good number of network, it will be very useful for the societal applications we can use. And another is like from the GPS, and another satellite geodesy called GRACE, gravity recovery and climate experiments data. If we combine together, we can very well measure the this is the equivalent of the groundwater level using because this is a gravity affected the satellite, and depends on the some hydrological mass. Then this the gravitational pull will be there, and using the GPS satellite we can measure that where are the possible area of groundwater potential area. This also the study has been done by my student Ajish P. Sajid. Now he is at SAC, and this is one of the important when in the newspaper. It was a very highly discussed paper, and we can because when we go for a measurement, we have to point we can. But using the satellite, we can very well map the groundwater potential area of the entire globe using this information. That is another important studies like this is the this also is a part of our work only. And apart from that one, if some earthquakes happen, I told the space science, when we go to the space science, when the earthquake happens, this the sudden slip of this tectonic plates, it will get disturbed on the surface as well as the water column. Like the Andaman earthquake. When the Andaman earthquake happened, then these water columns are get disturbed, and when this this will generate a acoustic wave, a sound wave. It will generate. This sound wave will generate much faster than the tsunami from this area to the coastal side, because tsunami happens. But then if this is in the case of an earthquake happen in the offshore. Offshore means in the ocean bottom. Then what happens? Suppose some earthquake happened in Andaman. Of course, there will be Port Blair all very close only, Andaman very close only. But if the tsunami generated from there, and it will take some time to reach our Indian coast. But these acoustic waves, when it generates from this one, and it goes to the ionosphere, which I told it's 85 to 300 kilometers away, goes there and disturb the electron content or the charged particles there. From there, this speed of this disturbance is comparatively quite fast. So that if we can track this information using the GPS at our suppose in Kerala coast or Tamil Nadu coast, before the tsunami comes, we can get some information that tsunami is going to come, because we can estimate that tsunami arrival almost 1.5 hour. That means 90 minutes before we can estimate using this GPS. And this is also a part of our study only. This is from the Andaman. We can from the coastal side if we have a GPS station, but like the precaution, so that we can warn the people. Tsunami warning system also we can make use of that one. And the same way, if some different types of deformation takes place, that pattern also will get changed in the atmosphere. That also we can make use of this GPS signal. And the very latest, or the one is that this was one of my another student. She is working on this area and using the same signals now, because Kerala coast is, we are very prominent with the monsoon activities. Suppose if because prior to the monsoon activity or flood or this heavy rains, there will be accumulation of water content in the atmosphere. If we have a continuous monitoring of this data, because of this water content, then signals again get delayed. And if we, these all the things, we should have a continuous monitoring. If this we can keep on continuously monitoring, and apart from other atmospheric equipments, this GPS same can be very cost effective way. These signals can be used for the information, the forecasting of the heavy rain or something prior to our heavy rain. And this is one of the studies one of my students, Dr. Rosemary, she is doing, and we compared with the rainfall and the water vapor, because we can what we from this GPS signal, from the delay, we can estimate the atmospheric precipitable water vapor estimate, and we can correlate with the rainfall, and we can forecast that some 5 to 6 hours prior to in a heavy rain. From using this signal and the cloud or water vapor content, we can forecast that there is a possibility of heavy rains using this type of GPS information. These are the different applications using a, and also of course for the Antarctica also we have studied some for the Antarctic plate deformation as well as glaciology, or the ice melting part using this GPS. And this is the, you see here, this is the conclusion figure from using a GPS receiver. You can lot of studies, you can snow depth, ice height, sea level, vegetation, soil moisture, because I did not touch all the parts, but ionosphere, troposphere, and so many, and including our tectonic, plate tectonic, water resources, glaciers, earthquakes, volcanoes. These so many informations using a single equipment and a single data we can be able, apart from our daily positioning. And this is one of the applications, and this is in the future also. This is a lot of the possibilities exclusive for the research and even job oriented part also. This is one of the good tectonic geodesy or space geodesy is emerging like any good subject. And I conclude with this figure, and my sincere thanks to again to the Sakradaya College and the authorities to invite me to for this seminar, and we wish you all the best, very best wishes to all my dear students, and hope we will in future will meet in either in CUSAT or somewhere else. Thank you very much, and if any questions you can ask. Thank you.
Thank you, sir, for your informative presentation, which had an amazing look through. Well, now participants, please do feel free to raise your doubts to our respected Dr. P.S. Sunil by unmuting your mic or letting yourself in the chat box. Please.
Sir, I have one doubt regarding the satellite communication system. Normally, the signals are getting on the daytime only. What about the night time? Are there any device for detecting the nighttime signals?
No, this satellite signal, it is a 24 all the time, 24 hours, 24/7. There is no difference in night or daytime. Anytime you can, anywhere in the globe, anytime you go. That's why only apart from, suppose if you are inside any building or some obstruction, you may not, sometimes you may not receive. Otherwise, anytime in the globe, even whether it is in the ocean, it's a deep ocean, like, Arctic, everywhere the signals are available. That is the way only they have made that constellation of the satellites. And that's why they are making it more expensive. And of course, for simple for a location, even you go with your what is a smartphone or a small handheld GPS, like what I showed, like anytime, irrespective of day or night, it will be available.
But a Garmin type GPS, various variant they have. The only you are getting the signals. Night time you are not getting, you know.
No, no, I don't think because I don't. It is not because it is made for to use anytime. Suppose we are see example in the if you suppose if you go to offshore or deep sea. If you don't have any GPS or anything, if it depends on night time, if they are not providing data, means it is not. We cannot imagine that situation, no. And for the aeroplane also it moves with the GPS only. We are maximum if we go to for long trip all night time only. All the time data is available. Maybe you can today itself you can try. Definitely, you just only thing you have to go outside to your building and it will be there. Definitely, no doubt.
Okay, thank you, sir. Any participants can ask any questions regarding.
Yeah, any question, not no any question you can ask. No issue related to this. Students.
Sir, there is a one funny question I am going to ask. So being a geophysicist, you know, I would like to ask, suppose the compass of the GPS, when you are reached at the exact north pole, it is not theoretically it is possible, but practically it's not impossible. On which direction the magnetic needle will reflect?
Because we know that because generally we talk in terms of geographic pole, and there is a difference between geographic and geomagnetic pole difference is there. And even I think you are talking not with the GPS, geomagnetic look this what we can say the compass direction. Your question is related to because generally when we talk, if the when we use a compass, geomagnetic compass, that that always shows a north direction, right? And that because generally what happens opposite that poles attract and same repels, right? And if the geomagnetic compass is showing north direction, but that is actually a geomagnetic south pole. That's why it is showing that one. And that, but again, the other confusion is that geographic north and geomagnetic north, that some angle, some 23.5 degree, or 11. Just I am confusing with the axis and this one, our axis of rotation and geomagnetic. That is 11.5 and 23 point are there. Now I confuse. Otherwise, that much angle difference is there, geographic north and geomagnetic north. And in terms of geomagnetic compass, when we go to the field, geomagnetic compass always shows a geomagnetic north direction, right? But actually, it is we are talking about terms of geomagnetic north is we are saying, but that is actually a geomagnetic south only because that is the way that it gets attracted to that direction. And I think in the compass also you must have, when we geologically also when we see whatever geomagnetic is, north is showing, this is supposed to be geomagnetic south because the poles are getting attracted, different poles are getting attracted. And GPS in the case whatever positions it measures depends on the terrestrial reference because we have a using this GPS and I told that we are very long baseline interferometry, then satellite laser ranging, different there is a terrestrial reference frame that is called International Terrestrial Reference Frame. From that one we measure all our directions from depends on the satellite and this condition in which direction we are moving and which because GPS that way no way connected with the geomagnetic poles or north pole or south pole. That is because earlier ancient period, do you know that not ancient, even earlier cases because of the geomagnetic compass only they start to move the sailors or the ship because we do before 98 there was no satellite system because they used to move with the compass only in different directions. But whereas once it started to GPS or GNSS, They now started to use this one. Even I think mobile also now we have the geometric the compass we can just for locating the north and south direction. That's all. That is locating the geometric north to north to the geographic north. I think that is clear, sir.
Yeah, it is very clear now.
Students, ചോദിക്കൂ. Actually, these seminars, I think sir is taking this much interest for all of you only. You can ask, because see, don't hesitate. Any sort of questions, whatever in your mind, you can ask. Because GPS only daily you use, no? Because you will be having a lot of dealings with the GPS signals. That also you can ask.
I think nobody asking the questions. Maybe or maybe lack of knowledge. I don't know. Okay, sir, I know you are one of the member for the Antarctic expedition team. If you don't mind, would you share some experience in the Antarctica?
Okay, actually, no, it is a nice question. Actually, our India since 1981, actually, 82, 81, we started our first expedition to Antarctica. And January next coming, because this is the 40th year, actually December, end of 1981 December, they started Indian Antarctic expedition. And our Indian scientific members, they landed on the icy continent, which is called Antarctica, on 2nd January. Because now coming January 2nd will be the 40th year of our India at Antarctica. That was the initiation of our then Prime Minister Srimati Indira Gandhi. That first expedition was led by Professor Siset Qasim, who was the Secretary of Scientist plus Secretary of Department of Ocean Development, DOD. Earlier that was called the Department of Ocean Development. Nowadays it is called Ministry of Earth Science. He was the secretary then. He was the director of National Institute of Oceanography, Goa. And he led the team of the first expedition. And it was one of the secret missions by India. Because when I was working in Indian Institute of Geomagnetism, one Professor Iyengar and one Professor Louis de Gross, they were the members, Professor Iyengar was the member of the first expedition. From his experience, I came to know that even when they have selected, it was almost like a 12 members, expedition members. When they have been selected for this expedition, it was very much secret, and even their parents or their family members, including wife, were not aware about that expedition. And after landing or reaching the landed on the Antarctica only, they could that the secret has to reveal even to their family members that they were, because they informed to their family members that under some their research investigation they are on the field. And because that time there was no much communication also. Even nowadays, even if we are missing for 1 hour from the home, we used to get a lot of phone calls or WhatsApp calls, but that days, even if there is no communication for 1 month, 2 months also, there was no issue. And even if then they go for the field work like the areas like Himalaya, or there was no communication for 1 month, 2 months like that. And their family members also know, they were not under any confusion. They thought, okay, they are going for some field work at Himalaya or some offshore offshore survey or like that, they thought. But after reaching there, only it was after the successful landing, then they could able to contact their family all, and they announced that successfully our India landed on the icy continent in Antarctica. And part of that, since then, every year now the other institute is under Ministry of Earth Science called National Center for Antarctic and Polar Science. It is NCP or National Antarctic. That they are every year they are keep on sending 40 members. The 20 members are for winter and the 20 members are for summer. That is, some winter means this winter members, they will be there for almost 16 months in the, you can imagine, 16 months at Antarctica, and the summer members for 4 months, they have to be there. Because I was, twice I visited there, I was a summer member. That means 3 to 4 months I stayed at this very cold, icy condition. And we have now the first our Antarctic station was with the Gangotri, that has been commissioned 84, because they landed this construction. They started 84 first commission. Now that because that was on a floating ice shelf near to the that means floating ice shelf. The ice shelf thickness is like a kilometer thickness, no? And but now it was totally immersed under the ice. And 1992 they have started it is second base station is called Maitri. That Maitri is functioning till now. It is very successfully going. And 2012 again we have our third station is called Bharati. That is a totally high-tech station. Now right now we have 2 stations at Antarctica. One is called Maitri, and almost 2,000 kilometers away from Maitri, in the periphery of the Antarctica, we have another station is called Bharati. Bharati station. 2 stations are there. It's both the places 365 days scientists and used to be there. And when we visited, I visited 2003 and 2005, the 2 times. And that time we used to start our because initial days from the start the travel was from Goa, because this NCPR is located in Goa. From Goa to Mauritius, from there directly to Antarctica by ship only. The continuous day ship. It was like they used to take 25 to 30 days, almost 1 month journey in one direction. But when we went there, that time we used to fly from Goa to South Africa. From South Africa, we used to go by ship. That time, from South Africa to this Antarctica, our Maitri is located. The place is called east. That is in the eastern part of the Antarctica. It's called Shimachar Oasis. We used to take 9 to 10 days to reach there. Okay, and the ship used to berth ship generally called berth or mooring. They used to call from that is in the icy shelf area. From there, almost 100 kilometers are there. It is our Maitri station is located. From there, we used to go by the helicopter, and we have a vehicle also there to travel in the Antarctica. And there a lot of research activities like earth-related, glaciology-related, atmospheric-related research activities are going on, including hydrocarbon type of but the Antarctica is not part of any of the countries, and there is a scientific advisory committee called Advisory Antarctica SCAR, and it's part of that Antarctic Treaty. Nobody can take any, or they can only do the research. Nobody can take any resource from the Antarctica. That is still a lot of countries are there. From I think from Southeast Asia, we have Japanese station, like Indian station, Japanese station, Chinese station. We all have. Major countries, and I think I don't. Pakistan or they don't have any station, but India is having. Now India is having 2 stations slightly it is running, and we used to go by the ship. And when we go, it was of course a terrific journey from roaring 40, shivering 60, furious 50, like that. Whenever we cross different latitudes, we will experience the what we can our real ocean, the nature, but nowadays if we can directly fly from here to South Africa to Antarctica also, our near to our Maitri station, we have another country station is called by Russian station is there. It's called Nova. They maintain an airport there. In the ice airport, in the sense the ice is like it's called a blue ice, which is like a rock only. In the top of this ice they maintain a station. That's why now the entire team don't go by the ship. half will go by flight and half will go by the ship. And the ship mainly for the all, because all the fuel, food items all carry by the ship only, because we have to run this both the stations almost 40 to 30 to 40 people are there now throughout the year. We have to maintain the station, run the experiments, feed the persons who are participating in this expedition, and all these food items, fuel items, all taken by in the ship only. And the main generator, the power system is by the generator, and it's called, the fuel is used for, it's called ATF fuel, and it's mainly that fuel is used for the aeroplane, because that doesn't get freeze. That's because otherwise the temperature goes minus 50, 60, minus 10. Because when we were there in summertime also, I have experienced the temperature up to minus 35 also sometimes it goes. But a peak winter time, it goes very below that also. And you must have heard that Antarctica, or and same condition almost in the Arctic also. Arctic is, we have a station is called Himadri, and that was commissioned during 2008. And there also this lot of research activities are there. But there we don't have a permanent station. We have a station that is for all the countries. Norway is running the one scientific village. It is called a Svalbard Scientific Village. There we have our own building, in a rental basis, and there we cannot go maximum at a time 8 people only can be accommodated. I was there almost four times. I visited that place also, and there also atmospheric, geological, air science, so a lot of research activities are going on. And the major another thing you must have heard, 6 months night, 6 months daytime in Antarctica. Whenever Antarctica gets, because that depends on because of our rotation axis, our direction. Because whenever Antarctica is not 6 months exactly, 3.5 to 4 months, when Antarctica is totally daytime, by that time Arctic will be totally dark. Then the transition starts another 2 months like that. Then when Antarctica became nighttime, that time Arctic became totally dark time. And here another very peculiar this is that because in our case the sun rises in east and sets at west, but there you can see the sun will move in the horizon only. You don't see like that, because when you daytime, this 4 months daytime, when you get up, because there is no day and night, you have to set up your body clock, and according some time we will be following. And when you get up, you will see the sun in some part of the horizon. When you sleep, also sun will be there the 24 hours, because we have to keep these curtains in the rooms and make it dark and sleep. That is only possible. The same way during a winter time, that means almost 3.5 to 4 months dark time, you don't see the sun at all. Wherever you go outside, see the total darkness. That is this one, and we can see the people over there like penguin in Antarctica. And when you go to the North Pole, there the dangerous is that, because Antarctica, even you wear the dress, it is called dagri, we can maintain our, suppose if you go for the field work to maintain the temperature, we have to special dress we have to wear. But there is no animals are there to attack us, because even if it's penguins or scuba birds, so they will be busy with their own business. But in Arctic is that where even if you want to go field, you have to carry the rifles, pistols all along with you, because there the dangerous person is polar bear is there. That is because once you go there, we get training for the rifle shooting, all those things. Then when you want to go for geological field work or any other field work out of this our station, we have to hire this one, carry this one. And of course, we will be very careful, and you have to see these polar bears are anyway, first, though if you have a rifle, after noticing, you have to run back and go to the station. That is the only first. When no other option, then only you have to use the rifle. But for me, luckily nothing happened in such a situation. But we have seen twice the polar bear, but they were quite far away. And these are some experiences. Sometimes I think even Davis permit. Sometimes we can exclusively have some talk to share my this one with some slides, photographs. Definitely. Thank you, sir. The students, these are some questions also. You can some general questions you can ask. Hello.
Students, participants can ask any question regarding anything. Okay, nobody coming then. Aisha, please.
Well, thank you all, and thank you, sir, for sharing your adventurous experience with Antarctica. And I'm sure most of us are just thrilled and inspired by your travelogue. And thank you. I would like to inform you all that the feedback form is available in the chat box, and I request every participant to fill it for the certificates. Richelle E. Goodrich said, "Gratitude paints little smiley faces on everything it touches." I call upon Nina Shine of first year geology to present the vote of thanks.
Am I audible?
Yes.
Yeah.
Good morning, everyone. Respected dignitaries present here, faculty members, and dear participants. Myself, Nina Shine, first year geology student. Let me first of all start by giving glory to the Almighty God for making today's occasion a resounding success. On behalf of Sahridaya College of Advanced Studies and Environ 2021, I would like to show courtesy to our chief guest, Dr. P.S. Sunil, Head Department of Marine Geology and Geophysics in CUSAT, who spared his valuable time for the webinar to help us explore more about how GPS is formed, what is GNS and GPS, how GPS is working, and its application in our day-to-day life. Thank you, sir, for the interesting and enlightening class. I would like to express our profound gratitude to Dr. Rani M.J., Vice Principal of our college, for the felicitation. My heartfelt thanks to the head of our department, Professor Davis KJ, and other faculty members of the department who have worked hard to ensure that this occasion become a memorable success. Finally, and yet importantly, a great appreciation to all the participants who chose to believe with us and attend the webinar with an inquiring mind and made it a successful event. Once again, thank you all for your presence and participation.
Thank you, Nina. Well, sir, I guess we have a question here. It's from Pratit K. He's asking if it's possible to get internship in these expedition programs as a bachelor student.
Yeah, actually internship program we don't they don't have actually when after your MSc you can apply for PhD programs or project programs there, and through that program you will be able to go, you know, you have to even with your some mentorship you can submit a proposal for the, you know, in the site, in the National Center for Polar Research, NCPOR site, all the details are there, even for the Antarctic and Arctic research. Of course, right, for the internship, you can carry out your internship there. There is no issue. But the visit to Antarctica may not be possible during that your internship period. Of course, you can apply your internship or a dissertation work in Shipyard, and they will, I think, definitely they entertain, and they take the students from our department also. Students stay every year, 2 to 3, sometimes 4 students they used to go there. But for to visit Antarctica or Arctic through that program, I don't think. But after completing your MSc, you definitely you can be able to join there, and you can, if you really wish, one day you can touch that land, any of this land.
Thank you, sir.
Dr. Sunil, now the
Yes,
students are over 3.
that's right.
They are over thrilled about that.
Okay. Thank you.
Thank you, sir. Thank you all. Tomorrow will be another awaited day of Environ 2021 with Dr. A.P. Pradeep Kumar, Professor at the Department of Geology at the University of Kerala, on the topic Tectonic Blocks and Mineralization in India, for which we all are excited about. So thank you, everyone. Goodbye and see you tomorrow.
Thank you once again to all of you, and wish all the very best wishes. And thank you,
Thank you, sir.
David sir. Yeah.
Presentation
Thank
and
you.
also good information. Thank you very much.
Thank you. Thank you. See you.